Hello students, as you can see on your screen, I have already uploaded 5 videos covering the first chapter of NCERT new book on mathematics for grade 6. So the first chapter is patterns in mathematics, and these are the 5 videos that I have uploaded. These are in Hindi. Now I have thought that along with these 5 videos, I will today upload, and as we will talk, learn about basic ideas in all of them together. So what I intend to do is do a theory revision on this first chapter, patterns in mathematics, and along with that I will be covering some competency based questions and answers. Okay, let's start. So this is the content. These are the various topics. So introduction to real life number and figure patterns. You might think that this video is very much different from the other videos. In a way, I have tried to give a different flavor of patterns in mathematics, both number patterns as well as shape patterns. Then we will consider few examples, then number patterns, and then this is an extra topic, general term of a sequence we will consider. Some of them will be important for Olympiad as well as all India level examinations. Now, introduction to real life numbers and figure patterns. You see, mathematics is the study of patterns and relationships. In our everyday life, we come across patterns which may consist of a repeated arrangement of shapes, colors, and or numbers. Now, when solving mathematical problems, one strategy that can be used is to look for a pattern, any repetitive arrangement. That is important. This is important. Okay. Now, a pattern in mathematics involves any predictable regularity. Now, around us, we may also find patterns involving figures and shapes. Say for example, Russian dolls in a shop. You can see, say if you go to a shop of toys, then see this hotel. In a hotel you can see this card showing the various room numbers. See, room 211 to 220, 221 to 230. So there is a pattern over here, a number pattern. Okay, here are even more of the patterns. Say for example, you see these instruments are kept, they are kept in a very nice arrangement. Okay, see, similarly fruits in a mall or in a shop, you can see the arrangement. This is basically a pyramidal type structure. Okay, we have not covered this, but the arrangement, if you try to do this is a 3-dimensional arrangement. Anyway, you see the structure in the flowers, this pattern. This is also very interesting. Another thing, see a calendar. Okay, now in the calendar for one particular month, if you look, then try to find pattern over here. See for example, there along the diagonal you see a pattern: 5 plus 6 11 plus 6 17 plus 6 23. See, the pattern goes on, plus 6 29. Over here along vertical direction, what pattern do you see? Again 6 plus 7 pattern, 13 plus 7 20 plus 7 27. See, patterns are everywhere. Here also you can see another pattern. More patterns. So these are plots for sale. Okay, see the number, the structure. Okay, there is a regularity sort of. Here also honeycomb structure, hexagonal structure. I have covered an entire video on this. Okay, next, pastries in a shop. See also the various patterns, the way they are arranged together. Okay, now let's start with number sequence. So a number sequence is a list of numbers where pattern is observed, and that pattern follows a mathematical rule. This is important. So, list of numbers, number 1, pattern is observed among them, number 2, and the most important thing is that that pattern follows a mathematical rule. Let's see some examples of number patterns. Okay, now sequences involving addition. See, suppose the question is write down the next two terms of the following sequences: 2, 5, 8, 11 and so on. Now you just write down the number line. So this is your number line. 1, 2, 3, 4, 5, 6, keep on writing. So you see 2 plus 3, if you do, then you get your 5. Similarly, if you do 5 plus 3, then you will get your 7 and 8. So here the rule is add 3, and this is how you get the various numbers. Okay, similarly here also 1, 5, 9, 13, you draw the number line. So here the rule is plus 4. So add 4, and this is how you get the various sequences, number patterns or number sequences. Okay, next, now for each of the following sequences write down the next two terms and the rule. Now I will not do all of them, but I will keep some of them for you for exercise. So just see over here, 3, 5, what's the difference? 2. Again 5, 7, what's the difference? 2. So this is basically plus 2, plus 2, plus 2. So the rule is add 2 over here. Next, over here, so this is 5 and half. What's this? Plus half. Again plus half, 6 and half. Again plus half, 7. Again plus half, 7 and half. So the rule is over here add half. So it's a fraction. Similarly here it's a decimal term. Okay, you can do this yourself. Next, sequences involving subtraction. The same old stuff goes just like addition. See, 15, 13, 11, all minus 2, adding. Okay, here the number line is written in the reverse direction. Normally it is written like this. Okay, you can also do like that, but it's okay. So the rule over here is subtract 2, and here it is subtract 3. See, 13, what is 10 minus 13? So the rule is, what is 10 minus 13? It is what? Minus 3. This is what is. Similarly here it is second term minus first term. So 13 minus 15. This is minus 2. That's the rule. Okay. Next, again you can do this yourself. Let me do the first one for you. So it is 90 minus 100. How much? Minus 10. So this is minus 10. Again this one is also minus 10. Again this one is also minus 10. So the rule is add minus 10 or subtract 10. Something like this. Okay. Next, sequences involving multiplication. See, for example, same old thing, 3, 6, 12, 24. Each time you are okay, so each time we have to do a multiplication just like this. Okay, and so the rule over here is multiply by 2. Similarly, see over here, 1 into 3, 3 into 3. Next again 9 into 3. So the rule is multiply by 3. Okay, now here again I have done one for you. See, so question part C, 6 into 3 18, 18 into 3 54. So the rule is multiply by 54. And the last one, sequences involving division. So see over here, just so 64, you see, divided by 2, 32, again divided by 2, 16, again divided by 2, 8. So the rule is divide by 2. Next, 81 divided by 3, 27, again divided by 3, 9, again divided by 3. So this is rule is divide by 3. Now interestingly, so if you get a series or sequence, you have to test among addition, subtraction, multiplication, division. So you have to compare the second term with the first term, and that's what you get, and then you have to check what you get. Say for example, say there are 4 numbers A, B, C, D. First you find the difference of them. Suppose in these cases, most of the time, say for example addition or subtraction case, over here, say for example here you are getting a constant number, say plus 3, again here the number was constant, -3, but in the case of multiplication the numbers will be different. Say for example here 6 minus 3 is how much? Say for example this one. See over here, this multiplication, this question, this one, we can do the analysis using addition as well. So this is what I am shown here: 3, 6, 12, 24, 48. So this is the sequence, say 48. Now if you do the subtraction, 6 minus 3 plus 3, again 12 minus 6 plus 6, so 6 plus 6, 12, 3 plus 3, 6, 6 plus 6, 12, 12 plus 12, 24, 24 plus 24, 28. Next, so this is the first difference. Next you find the second difference. Okay, see the second difference is plus 3 plus 6 plus 12. After that you try to find the third difference. See how much this is plus 3, how much this is plus 6, and so on. So if you see, if you find this difference also, if you are seeing a pattern, regularity in over here, so even if you don't do the multiplication, you can still generate using addition. So the game is like this: either you use this multiplication or you use this addition as well. In both ways you can see generate the sequence of 3, 6, 12, 24, 48. There are 2 ways: either you find this difference and find the pattern and then write it down, or try to see whether it is something other than addition, say multiplication or division or so. So that is the strategy, students. Okay, fine. So this is what I was telling you. Good. So here it is division: 64 by 2, 32, 32 by 2, 16, 16 by 2, 8, and so on. Okay, fine. Now after this, 4 examples of addition, subtraction, multiplication and division. Now we are ready to talk about the Fibonacci sequence. So look carefully. What do you see over here? See this diagram over carefully. Okay, see I have shown you in a zoomed version. So this is number 1. So 1 plus 1, this is equal to 2. So basically the first 2 terms, 1 plus 1, they are added and you get 2. Next you add 1 plus 2, this 2, then you get 3. Next you add 2 plus 3, then you get 5. Then you add 5 plus 3, then you get 8. So this is how it goes. Consecutive addition, you see, of last 2 preceding terms. Okay, so this sequence is the Fibonacci sequence. Okay, this implies that in order to obtain a term in this sequence, we need to add the 2 preceding terms. Say for example, this sequence 2, 5, 7, 12, 19, 31, 50 is also known as Fibonacci sequence. See over here, 2 plus 5 equal to 7. So to generate you need first 2 terms. Okay, so say for example I am writing the first term as A, second term as B. So the next term will be A plus B, right? And what is the term after that? The term after that will be A plus B, which is basically A plus 2B. Next term will be this 2 added. So it will be A plus 2B plus A plus B, which is equal to 2A plus 3B. See? So this is how the Fibonacci sequence goes on. Fine. So instead of numbers So basically you see, I have using just these two numbers we can generate the series. So see over here AB, all the other numbers are depending on this A and B over. Okay, so this is also, so I have showed you two examples. The first one was this one, and this is the second one, 2, 5, 7, 12, 19, 31 and 50. Now in fact, see the question over here, there are so many examples. You can create your own Fibonacci sequence as well. So you have to write down the next two terms in each case. Students, I am asking you to write it yourself. Say for example this one, 0 plus 1, 1, next 1 plus 1, 2, next 1 plus 2, 3, next 2 plus 3, 5, next 5 plus 3, 8. See, and so on and so forth. You can do the next yourself. Okay. Okay, now let us talk about the number patterns. Okay, that we get from patterns of figures. Say for example, consider this figure given below over here and answer the question. So this is figure 1. See 3 dots, figure 2, again some number of dots. So we have to draw the figure 4. That's the question, and complete the table. So what the table is, see the figure 1, 2, 3, 4 and 5, again figure 5 and so on. Now you have to count the number of dots. So it was 3, here 6, here 10. Can you recognize this sequence? Basically these are triangular numbers, students. We have talked about it in one of the videos. Explicitly I have discussed. Okay. So the next sequence is you just add one more row like this, and so it is generated, and then that is figure 4. Then after that again you add one more, and then you get figure 5. So this one is figure 4. See, this is figure 4. So this is how you generate number patterns from patterns of figures. Next question, you see the figures below have been formed using matchsticks, right? So draw the figure 4 and 5. So this is figure 3. Okay, now I have done this for you. Figure 1, 1 unit, 2 unit, 3 unit, 4 unit, 5 unit. Okay, now the question is how many matchsticks will be used in figure 10. So let us try to find it ourselves, if we can find some general rule. So how many matchsticks are there in this one? Say 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 matchsticks. Next one, again 1, 2, 3, 4, 5, 6, 7, 8. Right? 9, 10, 11, 12, 13, 14, 15. Now see, actually if I use the second one, so it will be 8 plus 8, 16. But since they share the common one, so 1 will be subtracted. So here it is basically 2 into 8 minus 1. Similarly, here will be 3 into 8 minus 1. So the 10th figure will be 10 into 8. What? Minus 1? No. Watch carefully again, students. So here it is 2 into 8 minus 1, since only 1 will be common. Next, in the case of figure 3, how many commons are there? 1, 2. So minus 2. So in the case of figure 10, there will be 9 common. So suppose I am asking you, say figure x, where x is some number, then it will be x into 8 minus x minus 1. That is the rule. See over here. See, in figure 2 only 1 common, in figure 3 only 2 common. Okay, so that's the rule, students. Now the question is, in which figure will 64 matchsticks be used? What do you think? Well, the answer is quite easy. It will be the 9th figure. Let me show you. Because in figure 9 it will be how much? 9 into 8, again minus 8. So this is, you see, 64. Okay, now next question, you see this is the diagram. So basically in this diagram table shows the small circles above the diagram. So the diagram number, things to observe. First is your diagram number 1, 2, 3, 4. Next, number of unshaded squares. Here it is 1, 2, 3. Here it is 1, 2, 3, 4, 5, 6. Here it is how much? See, 9. Next, here it is how much? 12. Okay, and so on. Next, total number of squares. It is just 2 into 2. Here it is 3 into 3. Here it is 4 into 4. Here it is 5 into 5. Fine, that we understand. So this is basically 5 square, 4 square, 3 square, 2 square. Next, number of shaded squares. So here is 1, here is 1, 2, 3. Next, here is how much? 7, and so on. So we have to generate the next ones. Okay. Okay, so I have already filled up this one. So 5 square, so this one will be 6 square, 36. Next, 7 square, 49. Now in the case of this number of unshaded squares, we see it is 3 into 2, 6. Next, 6. So we cannot just do the multiplication. There is no correlation. So this is 3 plus 3 basically. 6. Again 6 plus 3, 9. Next, 9 plus 3, 12. So next will be 12 plus 3. How much? 15. Next, 15 plus 3. It will be 18, and so on. And regarding the number of shaded squares, look at the sequence. It is 1, 1 plus 2, 3. Again 3 plus 4, 7. Next, the sequence will be either 2, 4, 6, 8, or it can also be like 2, 4, 8, 16, and so on. What do you think, students? Which one will it be? See, students, there is a fallacy. The problem is that here I have not done 1 into 2, but I have done 1 plus 2. Next I have done plus 4, not multiplied. So since in the first case I have done an addition, so I have to keep on doing addition. So this one is not correct. Okay, so it will be plus 2, plus 4, plus 6, plus 8. Next, plus 10, and so on. Okay, had it been multiplied by 2 in the first step, then I would have said something like this: multiplied by 4, multiplied by 8, multiplied by 16, multiplied by 32. So which is not the case over here. Fine, good. Okay, so I have completed the table over here for you. Okay, now we come to the last topic, which is the general term of a sequence. Now you see, the general term of a sequence is basically a formula that can be used to find a specific term in the sequence, and it is written like this: Tn subscript. Okay, basically you will learn about this rather when you start doing algebra in class 7, but I am just giving you a basic story about it. Say for example, if you are asked to find the first 5 terms for this sequence where Tn is equal to n plus 2. So you start like this. So Tn is equal to n plus 2. Right. Now you do like this. N is equal to 1. Then it is T1. It is equal to what? 1 plus 2, which is equal to 3. Next, n equal to 2, which is T2. And that is equal to again 2 plus 2, which is equal to 4. See over here, the other terms are done, and thus you can generate the sequence like this. Okay, so again here I have asked a question: generate the sequence if Tn is equal to 3n plus 1. So let us start. n is equal to 1, then t1 is equal to 3 into 1 plus 1, which is 4. Next, n equal to 2, t2, which is equal to 3 into 2 plus 1, which is equal to 7. Next, n equal to 3, which is t3 equal to 3 into 3 plus 1, which is equal to 10. Okay, so the sequence will be like 4, 7, 10 and so on. Remember, the sequence basically is t1, t2, t3, t4 and so on. Okay, so this is the basically general term. Next, we have this question: find the general term for each of the sequences below. 2, 4, 6, 8, 10. So you start like this. So t1 is equal to 2. So basically you identify like this. So you identify like this. This is my t1, this is my t2, this is my t3, this is my t4, this is my t5. So t1 is 2. So this I can write 2 into 1. Next, t2 is 4. I can write 2 into 2. Okay, so there has to be something 1, 2 over here, 3 which matches with this 3. This 2 matches with 2. This 1 matches with 1. So basically these are the general terms of Tn is equal to twice n. Next, see over here. Again, 1. I can write 1 into 1. Next, 2. I can write 2 into 2. Next, 3 into 3. 4 into 4. 5 into 5. Or the general term will be n into n, which is n square. So basically here Tn is equal to n square. Okay, students. And finally this one. 4, 7, 10, 13, 16. So I can again write like this. 4, I can write 1 into 3 plus 1. Again 2 into 3 plus 1. T2. So basically here the Tn is 3n plus 1. Okay, good. So with this we have come to the end of this video. We have discussed very different type of questions. Most of them have not been covered in the NCERT book. So I wish you best of luck in your studies. Okay, if you have any questions or comments, do ask me.